This is lesson 3 from Unit 5, graphing polynomial functions. So you've already learned how to graph functions like binomials. Here's an example of a binomial. If I gave you graph paper, you'd feel great, binomial. And you've learned how to graph trinomials. Not a problem, it's a quadratic equation. You felt good about that. Now we're going to learn how to sketch graphs of polynomial functions. So polynomial functions have 3 rules to them, 3 major rules. One is the exponents are never negative, so no negative exponents. Also, the exponents are never fractions. And lastly, variables cannot be found in the denominator. So I'm going to write down an example of a polynomial. Y equals 3x to the third plus 4x squared minus 5x plus 2. That's an example of a polynomial. When I look at the exponents, they are not negative, they are not fractions, and there's no variables in the denominator. Sometimes for students, seeing an example of what it can't be helps them. So I'm going to do that right now. Y equals 3x to the negative 2. This is not a polynomial. We have a negative exponent. Y equals x to the 1/2. This is not a polynomial. We have a fraction in the exponent position. And lastly, y equals 3x squared plus 2 over x minus 5. This is not an example of a polynomial because we have a variable in the denominator. The next learning objective we're going to do is we're going to talk about when we look at an equation, what would be the degree and what would be the leading coefficient, and that's going to lead into end behavior. So let's write down a few examples. A equals 3x to the fourth plus 6x cubed minus 5. I'm going to leave a little space to come back and do end behavior. B equals negative 2x to the fifth plus x to the fourth plus x squared plus 6. C is 1/2 x to the ninth minus 2x. And finally, D equals negative x to the 8th plus x to the 7th plus 3x to the 9th minus 4. So a couple terms that you may or may not be comfortable with would be leading coefficient and degree. Degree represents the highest value in the exponent position on a variable. So here we have degree 4, this is degree 5, this is degree 9, and this is degree 9. Unfortunately, they're not always organized in standard form. Standard form is the highest exponent down to the lowest, highest to the lowest, highest to the lowest. Here, I purposely threw in and did not put it in standard form. So this is degree 4. I'm abbreviating. This is degree 5, this is degree 9, and again degree 9. Next is the leading coefficient. Once you've identified the degree, the leading coefficient is the value directly in front of the variable. So I'm going to abbreviate. The leading coefficient here is 3. The leading coefficient here is negative 2. The leading coefficient here is 1/2, and the leading coefficient here is positive 3. Okay, so how does identifying the degree and the leading coefficient help us in sketching a graph? Remember, we're not using a calculator as we sketch the graph of these polynomial functions. So when we look at our functions, there's 2 parts. We're going to talk about what's in the middle, and that's going to be determined by our x-intercepts and by our y-intercept. And then we're going to talk about the ends. When we talk about the ends, we're talking about the far left and the far right. So let's start with how do we talk about the ends. On the ends, we're going to see functions that maybe look like this. You're just watching. So maybe they go up on the left and up on the right, or maybe it's the reverse. Maybe they go down on the left and down on the right, or maybe one goes up on the right and down on the left, again, or vice versa. So we can make that identification by knowing the degree and the leading coefficient. So again, we're talking right now about, it's called the end behavior. We're talking about what's happening on the ends, and we're going to talk about next, or in the next 5 to 10 minutes, about what happens in the middle. When I look at this first example, we said degree 4. Okay, 4 is an even number. With degrees, you're always going to say even or odd. So we have an even degree, and our leading coefficient was the positive 3. We have a positive leading coefficient. So I look on my chart, and I'm looking for even positive. Even positive says it's up on the left and up on the right. So when I think about this graph, I know in the far left and the far right, it will both be going up. Let's look at example number 2 from this. The function b of x. We have degree 5. 5 is an odd number. The leading coefficient is negative 2. That is a negative number. Degree will always be classified as even or odd. Leading coefficient will be classified as positive or negative. So I'm looking on the chart, I'm finding odd, negative. Odd, negative. Okay, odd, negative says up on the left and down on the right. Odd, negative. Up on the left, down on the right. Up on the left, down on the right. What's happening in the middle is what we'll determine again in 5 to 10 minutes. Okay, let's go to c of x. Degree 9. 9 is odd. Leading coefficient is 1/2. 1/2 is positive. So I'm looking for odd, positive. Odd, positive says up on the right and down on the left. Up on the right and down on the left. And our final one is odd, positive again, because 9 is odd and 3 is going to be positive. So it's going to look just like this example. All right, here we go. Now we're going to incorporate that middle section. Okay, we're now going to add in that middle section. So the middle section is going to incorporate those x-intercepts. I love this form. It's already factored for us, and I like it in factored form because when the degree is 1 of each of these parentheses called factors, and when the leading coefficient is 1, I don't have to do any work. All I have to do is ask myself, what's opposite of negative 2? What's opposite of positive 5? And what's opposite of negative 6? So I get an answer of 2, 2, negative 5, and positive 6. These represent the x-intercepts. Now, x-intercepts on our graphs could also be called solutions, and they might also be called zeros. Before we start to graph that, we need to talk about when we have an x-intercept, the interaction between the line of the graph and the x-axis may look different. So please write this down. We can have a single solution. We can have a duplicate or a double. Some people just like double solution. And we may have a triple solution. And the way that the graph interacts with the x-axis will all look different. I'm going to choose an arbitrary number. That just means a random number. So let's go with the value negative 1. If we solve and we only see negative 1 listed one time, we'd say we have a single solution of x equals negative 1. What does that mean? That means when our graph goes through the x-axis at negative 1, it's going to cut through. So where you see single solution, please write cut through. Now, here's an example up above. Does everybody see where you see 2 listed twice? Does everybody see this? It's a double or a duplicate solution of 2. So if we saw negative 1 listed twice, we need to bounce off the x-axis. So I'm going to go to negative 1, and it's going to look like this. It's either going to come from the top, bounce off and go back where it came from, or give you another example, it may have come from the bottom, it comes up and then bounces off, but it's going to go the same direction it came from when we have a duplicate solution. What happens when we have a triple solution, like x equals negative 1 3 times? Then we use the word it snakes through. So I'm going to go to negative 1, and when it snakes through, It approaches the x-axis and then it becomes flat or parallel to the x-axis for just a short period of time before then going through. There is a difference in what a single solution and a triple solution looks like. Now, how can we use that information to go ahead and graph what we see up above? So I'm going to take this. Raise your hand if you need a little extra time to write these down. Okay, I will press pause. Use that information to now graph. So please make yourself not a detailed graph. You're literally going to make a line for the x-axis and a line for the y-axis. Nothing more than that at this time. I'm going to start by identifying the x-intercept. So I'm going to go to positive 2, negative 5, and positive 6. I need to know where are the x-intercepts. I need to know how is the graph going to interact with the x-axis. So I have a duplicate, it's going to bounce off. These are singleton solutions, so it will cut through. And then lastly, I need to apply the end behavior. Please write down and let's abbreviate. This is going to be the degree and the leading coefficient. Now this looks slightly different than what we worked with before when we were practicing identifying the degrees. So the degree is we need to know how many x's do we have. 1, 2, 3, and 4. We have 4 x's. So it's degree 4, and 4 is an even number. And then the value directly in front of the x's would be 1 times 1 times 1 times 1. The leading coefficient would be 1, and 1 is a positive number. Please go to your notes and look at the end behavior chart. Please identify the position that has even positive. Even positive says up on the right and up on the left. Up on the right and up on the left. So we're going to go to the very ends that we have, the two end x-intercepts, and we're going to go up on the right and up on the left. Now, at positive 2, I know it needs to bounce off. And at negative 5 and 6, it's going to cut through. So it cuts through way over here at negative 5. And I need to get from negative 5 all the way to 2 without crossing the x-axis. Now, I'm going to show you the correct way. Please watch. Here's the correct way. Before I get there, I did have students in earlier periods say, like, Ms. Bradley, how do I know if I should go up or down? Well, if you chose to go up, does everybody see how this looks like a double? Does everybody see it? But we didn't have a double solution at negative 5. There's only one, so it has to be a single. It has to just cut through. It cannot be a double. That's what tells you whether to go up or down. So I go down. When I get to 2, I have a duplicate solution, so it needs to bounce off. And then it comes right back to 6 that cuts through, and this problem is done. All right, so our second example in this form. By the way, remember x squared is the same as x times x. And so for this problem, let's start by identifying the degree. That means how many x's do we have? 1, 2, 3, 4. So again, we're on degree 4, which is an even number. And the leading coefficient would be the values in front of the x. 1 times 1 times 1 times 1, which would be positive value. I'm going to go over to my end behavior chart, and I'm looking for even positive. Even positive. Even positive says up on the left and also up on the right. Up on the left and also up on the right. Okay? Next, whenever we find what's happening in the middle, we're identifying those x-intercepts. We need to make the y value, or in this case, the g of x, equal to 0. And then I like this form. When the degree of each of these is simply 1, it makes it easy. I can take each of these and I can set them equal to 0 and solve. So each of these is set equal to 0, and I end up with x equals negative 2, x equals positive 4, and x equals 0, and x equals 0 again. So I have 4 different solutions. Let's come down to our graph, and let's graph 0, negative 2, and positive 4. Okay, I'm going to apply the end behavior. The end behavior says on the far left and far right. You're going to your last point or x-intercept on the right and the left, and we're going to go up in both directions. So up on the left and up on the right. Now we have a duplicate at 0. So at 0, it has to be a duplicate. If I go down to get to, excuse me here, I did the wrong thing. At -2, it's just a single. At -2, it's a single. So I need to go down. I can't go up, because if I go up, it looks like it bounces off, and it's not a double. So I'm going to go down, and then as I come to 0, there's a duplicate, so it has to bounce off at 0, and then it keeps going down and comes up at 4. This one together. Now I could expand this if this helps you. We're writing just this base 3 times. Okay, are you ready? So degree 1, 2, 3, 4, 5. This is degree 5. That is an odd number. Leading coefficient, -1 times 1 times 1. That's -1 still. Times 1 times 1. Still -1. So please do me a favor. Take out in your notes and find your end behavior chart and find odd negative. Odd negative says up on the left and down on the right. Up on the left and down on the right. Now, I personally like this form. When the degree is 1 in each of these, we can easily, and the leading coefficient is 1, we can easily identify without having to say x minus 2 equals 0 and then adding 2. We can quickly identify it as being a positive 2, bless you, as being a -3. Now, each one of these, when I set it equal to 0, will just be 0. So I have 3 solutions, 3 zeros, 3 x-intercepts, all of 0, and then I additionally have an x-intercept of -3 and a positive 2. Please make yourself a very simple chart. Sure. Here's 3, 4, and 5. Yep, good question. So we're going to go to 0 and make a dot. We're going to go to -3 and make a dot, and to positive 2. So I've identified the x-intercepts. Now I'm going to apply the end behavior. So on my last x-intercept on the left, I'm going to go up, and my last intercept on the right, I'm going to go down. At -3, it's only a singleton solution, so I just need to cut through. At 0, it's a triple. Does anybody remember what's the word we use at a triple? Snakes through. So it's going to come up, then it goes flat, and then it goes up again. And then at positive 2, it's only a singleton answer. It just goes through. Slowly start as students in class are finishing to describe this. 1, 2, 3, 4. This is degree 4. 4 is an even number. Now, leading coefficient is kind of confusing. -2 times 1 is -2. -2 times 1 is -2. -2 times, I think I said that wrong. This is 1s here, right? So if I go backwards, 1 times 1 times 1 times -2 is just -2. All right, so I'm going to look right now at my chart, and I'm trying to find even negative. What's happening for even negative? It is going to be both down. So both down. Okay, now I like this form because I can quickly solve. One answer is -2. One answer is +3. One answer is -2. The only number you can take times -2 and get 0 is 0. You could also set each one of these quantities equal to 0, did all the math, and receive the same answer. So I'm going to go to -2, and I'm going to go to +3 and 0. Now my end behavior on each of the ends, I'm going down. Okay, now I've got to think about this. At -2, what do I have, kiddos? I have a duplicate answer, so it has to bounce off. So it comes the same way it came. But at 0, there's a singleton answer, so it cuts through. And at 3, there's a singleton answer, so it cuts through. Done. I'm going to take it one step further. The only difference between the last 3 to 4 examples and this example is it's not currently in factored form. So I'm going to start out the exact same way. I'm asking myself, what is the degree? It is degree 3. That is an odd number. And the leading coefficient directly in front is a hidden 1. That is positive. that I'm taking this out and I'm finding odd positive, up on the right, down on the left. So I'm going to do that. Up on the right, down on the left. But notice that this does not have right now it in factored form. So I'm going to write this in factored form, going back to what you learned in Algebra 1, 2, and then I'm going to solve it. So I'm going to set it equal to 0 here as I factor and solve. In these first two positions, I can factor out at most an x squared. X squared times x is x cubed. X squared times 5 is 5x squared. Whatever is in parentheses comes in back with a little question mark in front. What times x is negative 16x? Negative 16. Now I got to make sure I did that right. Negative 16 times 5 is negative 80. Okay, I'm feeling good. The front and the back, they both contain the parentheses x plus 5. I write it down one time. In front of the first parentheses is x squared. In front of the second parenthesis is negative 16. I'm going to take both of these parentheses, set them equal to 0, and solve. X plus 5 equals 0. X squared minus 16 equals 0. And I do all the math, and I get one answer of negative 5. And I have another answer of plus or minus 4. So I'm going to go to a graph, a very simple graph. I'm going to go over to negative 5, and to negative 4, and to positive 4. Are there any duplicates or triples here? No. Nope. Okay. On the very far right x-intercept, I go up. On the very far left x-intercept, I go down. Now here is what is different. The only extra thing you need to add in is they want you to identify the y-intercept. That's going to be the constant, the number that's by itself with no x. So I'm not going to go all the way down to negative 80. That's not realistic. So I'm just going to put negative 80. Okay, cuts through, problem is done. So if you are home, you are going to take out your packet and find lesson 3. We're going to practice a few questions together to ensure you know what you're doing here. So we're going to start off by identifying the degree. This is degree 3. Behind it, I'm going to write odd. And we have a leading coefficient of 2, which is a positive number. Okay, please do me a favor and look into your notes. I want you to find odd positive. Odd positive. It's right here. Up on the right, down on the left. Up on the right, down on the left. Okay, next up, we want to factor and solve this, which means I'm taking that y, or f of x value, and I'm replacing it with 0. If you want to do this on a single notebook paper and then attach it, that would be fine as well. In these first two terms, I can factor out at most an x squared, and I'd be left with 2x plus 3. If I distribute it, I get 2x cubed plus 3x squared. Then I'm asking myself, what value can I take times 2x, and I end up with negative 32x. Anybody know the answer? Negative 16. Negative 16 times 2x is in fact negative 32x, and negative 16 times 3 would be negative 48. We've done all the hard work. Okay, next up, here we go. We have a front and back. They both contain a 2x plus 3. In front of the first group of 2x plus 3 is an x squared, and in front of the second group is a negative 16. I'm going to take each of those factors at this time, and I'm going to set it equal to 0 and solve. So I'm going to subtract 3 to the opposite side, and then I'm going to divide by 2. And you can leave it in fraction form. Also, by the way, negative 3 halves is equivalent to negative 1.5. Then I'm going to add 16 to both sides, taking the square root, and I get plus or minus 4. Yes, Al, do you need another pencil? Okay, here we go. Well, let's graph. Let's go to positive negative 4. And let's go to negative 1.5. Notice that my end behavior says the last x-intercept, we're going to go up on the right, and the last x-intercept on the left, we're going to go down. That's my end behavior. We also want to identify the y-intercept, which is this constant value. I'm not going all the way down to negative 48, so just make sure to make a dot at the end of the graph and identify it by the value. I have three different solutions, negative 1.5, positive 4, and negative 4. None of them are duplicates. That means I'm cutting through, I'm cutting through, and I'm cutting through, and this problem is done. Okay, our second example when it's not in factored form. I look at this problem and I'm like, oh, yuck. One, we have a leading coefficient that's negative. I don't like factoring with that. And two, those are really large numbers. So I'm going to see, can I factor out a negative 3? Now, here's how I can tell if I can factor out a negative 3. I can divide this by negative 3, and I get a nice even number. It's not a decimal. I can divide this by negative 3, and I get a nice even number. So I'm going to factor out at this time a negative 3. Okay, let's get started then. Degree and leading coefficient. We have degree 4, which is even, and we have a leading coefficient of negative 3, which is negative. Look onto your chart. What does even negative look like? It's going to start to become, what does it look like with those arms? Both down. Okay, I'm factoring this part. I'm not worried about the negative 3 out front that we factored because there's no variable with it. I'm trying to solve right now for the x-intercepts, which means my y value is 0. What multiplies to equal positive 36 and combines to give you negative 13? Negative 4 and negative 9. Okay, now here's a part where a lot of students make a mistake. They want to leave it as x minus 9 and x minus 4. You need to take this number and evenly divide it. So this is going to be a square and a square. And now when I solve it, I see three different parts, but if it doesn't contain an x, I don't have to worry about solving it. So I'm taking x squared minus 9, setting it equal to 0, and x squared minus 4, setting it equal to 0. You're going to show all of your work, and you end up with positive and negative 3, and positive and negative 2. So for the purpose of time, I'm just speeding this up a little bit. I'm going to go over to negative 2 and to positive 2, and to positive 3 and negative 3. Also, notice my y-intercept is way down here at negative 108. On the left and on the right, I'm headed down. That's the end behavior. Each one of these is only listed once. There's 1, 3, 1, negative 3, 1, 2, 1, negative 2. So I'm cutting through, cutting through, cutting through, and cutting through. At this time, please take out your homework. I want you to turn right now to problem number 1 in the homework, and students in class are working on number 1 from their homework. At the same time, I'm going to do it here. So I can see this is degree 4, which is even, and we have a leading coefficient, which is 1, and that is positive. So even positive means up on the right and up on the left. Okay, now let's set this equal to 0, and let's ask ourselves, is this factorable? So what multiplies to equal 9 and combines to give us negative 10? It's going to be negative 9 and negative 1. They multiply and they combine. So x minus 9 and x minus 1, and here's where a lot of students make a simple mistake. Remember, this has to be divided evenly to get x squared and x squared. Taking each one of these, setting it equal to 0, and solving. And here I have my 4 different solutions, or zeros, or x-intercepts. Yes, that's what the rubric says for grading. You do have to show the work. I know it. So I have solutions at negative 1, negative 3, positive 1, and positive 3. I also have a y-intercept way up here at 9. My end behavior is up. And now I can see each one of these solutions is only listed once. And so I'm going to go down, back, down, and back. This is the last example before we try one like this in your homework. Why do students, including myself, look at this and say, oh, this looks ugly? Because we have a fraction and our leading coefficient is not 1. So let's factor this out. So let's put a negative 1/2 out front. And by the way, there's 3 x's, 2 x's, and 1 x. I can factor out an x. So I need to figure out what goes inside of here so that if I distribute it, I came up with this. Well, negative 1/2 times 1 is negative 1/2, but I need 2 more x's to get up to x cubed. I know a negative times a negative would give me a positive, and I need one more x to get x squared. But what value here? So this is the way you can think of it. When you multiply by 1/2, you're really dividing by 2. So what value divided by 2 gives you 4? 8. So this is 8x. A negative times a positive would equal a negative when you distribute. And again, what value divided by 2 gives us 6? 12. Okay, before I get any further, let's look at this. We have degree 3, so it is odd. We have leading coefficient of negative 1/2, and that is negative. So look at your thing really quick. What does your table say when we have odd negative? Odd negative is up on the left and down on the right. Up on the left, down on the right. Okay, now I'm going to quickly factor this. What multiplies to equal 12 and combines to give us 8? Anybody want to shout it out? 6 and 2. 6 times 2 is 12. 6 plus 2 is 8. So this is x plus 6 and x plus 2. Now what I've not shared with you is when you have a leading coefficient that's 1 within this factor in the degree 1, remember you can be lazy. That's why I liked this method. What's opposite of positive 6? What's opposite of positive 2? And now what's the only number that you can take times negative 1/2 and you get 0? 0. Those are my 3 x-intercepts. So I'm going to come over and find negative 6 and negative 2 and 0. I'm going to apply the end behavior and then realize that each one of these was only listed once. That means I'm going to cut through, and cut through.